Two blocks are connected by a light string that passes over a frictionless pulley as in figure P5.38. The system is released from rest while M2 is on the floor and M1 is a distance h above the floor. So that is the initial condition, right? And the picture is like this, right? So this was the initial condition. And then assuming M1 is heavier than M2, find the expression for the speed of M1 just it is reach the floor. So here, because M1 is heavier than M2, it will move down, right? It will move down and eventually it just reach the floor with some speed V. And here we have also M2 goes there with the speed of V. Why? Because it is moving as one system. And the height of M2 here will be the same as this h here. So that is the picture for question A, right? And we can answer this using conservation of mechanical energy. So the mechanical energy in the initial state will equal to the mechanical energy of question A here, right? And here we have only the potential energy of M1. So I will have potential energy of M1. And that will equal to, we don't have any kinetic energy here. And also we don't have any potential energy here because we use the ground here as our reference. And then on this condition A, we have potential energy of M2. So I will have potential energy of M2. And then we also have the kinetic energy of M1 here, right? It is going down with speed of V. It is not reached the floor yet because it is just as it reached the floor. So I will have only kinetic energy on M1. And then we also have the kinetic energy of this M2 here. So kinetic energy of M2. So we will have this one here. So we will have M1 multiplied by G and then multiplied by H. And then for this one, the potential energy of M2. So we will have M2 also multiplied by GH. And then plus we will have 1/2 M1. And then the speed is V squared. And then plus 1/2 M2 multiplied by V squared, right? Okay, now let's move this to the left-hand side. So I will have M1GH minus M2GH, but we can factor out the GH. So we will have M1 minus M2, then multiplied by GH. Okay, and then we also have 1/2 here. And let's factor out V squared. So I will have M1 plus M2 and then multiplied by V squared, right? And we can multiply both sides by 2 and we can isolate for V squared, right? So we will have V squared here is 2 multiplied by M1 minus M2 multiplied by GH and then divided by M1 plus M2, right? And we can isolate that for P. So we will have the square root of all of them here. So I will have 2 multiplied by M1 minus M2, then multiplied by GH, and then divide that by M1 plus M2. Good, and that is the answer for question A. The expression for the speed, which is this one. And B, we are given the numerical values of M1, M2, and H. So for question B, we will have M1 here. That will equal to 6.5. And then M2, that will equal to 4.2. And then the H is 3.2. And we can just plug this into this formula here. So I will have V here. That will equal to, maybe let's just plug that into calculator, right? So we will have the square root of, we will have 2 multiplied by M1. M1 is 6.5. And then minus M2. M2 is 4.2. And then multiplied by G, which is 9.8. And then multiplied by H, which is 3.2. And then we will have M1 plus M2. So I'll have 6.5 plus 4.2. And I will have 3.67. So I'll have 3.67. And the unit here will be meter over second. So that is the answer for question B. Right? And then what else that we have for question C? Find the speed of each block when M1 has fallen a distance of 1.6. So here we will have 1.6 meter. 1.6 meter. However, that means that this height here of both two blocks is this one here. Okay, let's name this as H1 here. And that will be, because this H is 3.2 meter, we have down 1.6, it has to be 1.6 meter, right? So we need to do conservation of mechanical energy, but for this system here, for question C. Okay, maybe let's clean this up and answer question C. Okay, now for question C, we have the mechanical energy of the initial state is equal to the mechanical energy of C, right? Problem C. And in this system, we only have potential energy of M1. We don't have any mechanical energy, any other mechanical energy. So I will have potential energy of M1. Okay, but in this C here, I have the potential energy of M1, but M1 here is moving down, right? So this is moving down like this. So I will have kinetic energy of M1. And then I also have potential energy of M2, right? So potential energy of M2 because it is stays in H1 here now. But then it also moving upward with some speed, right? So I will have plus kinetic energy of M2. Good. Now let's plug in the formula. This one will be M1 multiplied by G multiplied by H, the original height. And that will equal to this one, M1 G, but this one, the height is different. So I'll have H of 1. And the kinetic energy, so I'll have 1/2 the mass of 1 multiplied by V squared. And then plus potential energy of M2 in this case, so I will have mass number 2 multiplied by G multiplied by H1. And then the kinetic energy is 1/2, and then M2 multiplied by V squared, right? The speed is the same here, V and V, because they are moving as one system. Okay, now let's plug in the numerical values. M1 is 6.5 kilogram. G is 9.8. And then H here is 3.2. Good. Then on the right hand side, I will have 6.5 multiplied by 9.8 multiplied by 1.6. And then we will have plus 1/2 multiplied by 6.5. Right? We will have 6.5 and then multiplied by V squared. And then plus mass number 2. Mass number 2 is 4.2 kilograms. So I have 4.2 multiplied by 9.8 and then multiplied by H1. H1 is 1.6. So I have 1.6. And then plus we will also have 1/2 multiplied by mass number 2, which is 4.2, and then V squared. Good. Now let's calculate the numerical values. So we have 6.5 times 9.8 times 3.2. Okay, we'll have 203.84. 203.84. And then this one here, I will have this one here as 1.6, right? And we'll have 101.92. Okay, and then I think I will calculate that first. So we'll have 4.2 times 9.8 times 1.6, and that has to be 65.86. 65.86, and then let's add up the p-square term here. So I will have 1/2 multiplied by 6.5, and then plus 1/2 multiplied by 4.2, and I will have 5.35, and that will be v squared, right? So we can use that for our left hand side. 5.35 v squared, and that will equal to, we have 203.84, and then minus 101.92, and then minus 65.86. Then I will have 36.06, 36.06, or we can divide that by 5.35. So I will have v squared here is 5.35 divided, no, 36.06 divided by 5.35. So I will have 6.74, 6.74, and so we can take the square root of it, and we will get the answer, the square root of 6.74. That will be 2.60, right? So I have 2.60, and the unit here will be meter over second. And that is the answer for question C. Okay, hopefully I did not make any mistakes during my calculation. Thank you for watching. See you in the next video. Bye-bye.